Hi students, I thought to discuss about chapter 2. Chapter 2 we talk about atoms. What is atom? Atom is the smallest quantity of matter around us. Everything you see is matter. A single speck of dust has millions and millions of matter in it. So matter, early scientists, they start working on matter. They do a lot of research. Um, like there are some prominent scientists, J.J. Thomson. J.J. Thomson, they want to find, okay, so how the structure of atom. So J.J. Thomson did a lot of experiments and he found a plum pudding model, and then everybody started believing it. But then his student Ernest Rutherford did the nuclear. He invented the nuclear model, nuclear atomic structure. What he did was, the Rutherford's nuclear experiment is very important. What he did, he took a piece of gold foil. You can think about aluminum foil, very thin gold foil, and he passes alpha particles through it. When he passes alpha particles through it, he noticed that majority of particles going through this gold foil. But once in a million of particle deflects, extremely small amount of particles deflects. Why is that? He found, okay, the matter consists of a, like in matter, the mass is consist of a small area that is called nucleus, and then this lead to finding of subatomic particles. Subatomic particles are neutrons, protons, and electrons. Nucleus has protons and neutrons. Outside, electrons. Protons positively charged, neutrons no charge, electrons negatively charged. So this is the summary of that. And then there is another important thing we are going to: atomic number, mass number, and isotopes. What is atomic number? Atomic number is number of protons in an element. So number of protons is unique. It defines an element. One atomic number, like none, there's no way two elements sharing same atomic number. Example, you have atomic number 6 for carbon, atomic number 7 for nitrogen. So it's completely different numbers. So you see, and then there's another number comes, that is mass number. Mass number is number of protons and neutrons in an element. So this is the representation you can see in the screen of an element. X atomic symbol, Z is the atomic number, A is the mass number. And isotopes, some of you may have heard about these isotopes. Isotopes are, they have the same atomic number because it's the same element, but they have different mass numbers. Example, hydrogen 1 1, 1 2, 1 3. So if you look at this one of this element, you see this is the atomic number. This is the mass number. Atomic number is number of protons. This is mass number. So according to this, how many protons? 1. How many neutrons? 1, right? But if you look at this one, all these three has 1 proton, right? 1 proton, because it's number of protons, atomic number. But if you think about this one, you have mass number, which is, you already know you have 1 proton, 1 neutron. Here 1 proton, 2 neutrons. So I have some determine the numbers of proton, neutron, and electron each of the following species. Cl1735. So if I'm asking, okay, if I take this A, number of protons 17. How many neutrons? 35 minus 17, which is 35 is protons plus neutrons. So that's what I said. Okay, 35 minus 17, 18. How do you know number of electrons? Always, if the element is neutral, no charge, number of protons and neutrons are same. Sorry, number of protons and electrons are same. Okay, so now I'm going to the average atomic mass. average atomic mass is, if you can see in this periodic table, I have the periodic table open here. Let's look at carbon. So this is the 6 is the atomic atomic number, 12 is the mass number. So what is that 12? 12.0, is it mass number? It's not a mass number. That is the atomic weight. So if I have the element C6, 12.00 something, so got it, that's 0.1. So this is the atomic number. This is the atomic mass. How do you find the atomic mass? All these elements in the periodic table, they have isotopes, but they have different abundance. Example, carbon has 2 isotopes, C12, C13. But if you think about abundance, if you take 100 grams of carbon sample, 98%, 93 you get C12, 1.07 you get C13. So you take the both isotopes into account. It mostly goes towards this 12 because you have majority of the 12. So you take the mass of the isotope multiplied by natural abundance. That's what I did here. Mass of the isotope, natural abundance, plus mass of the second isotope, natural abundance. See, 12.01. That's what listed in the periodic table. So the atomic mass measured by the mass spectrophotometer. And then the next important topic, periodic table. Periodic table is very important in chemistry. In the exam, you will get periodic table. So if you're familiar with the periodic table, it's very easy for you. So periodic table has the classification, metals, non-metals, metalloids. You see this gray area, metals, blue, non-metals, the brownish orange color is metalloids. And also we need to look in the periodic table. Let's get a pen. Group 1. Group 1 we call alkali metals. I think I can't write it. Alkali metals. Group 1, this I'm using. Okay, you can also have the periodic table and then you can color it. And then you can write, okay, this is the alkali metals. And then I'm going to take another color. Like this, and then I write these group 1 alkali metals, group 2 alkali earth metals, and then you have your group 8. These are, what are these? These are noble gases, halides, another color, let's pick, halides, and then chalcogens. So this is the main classification, and also we classify main group elements, transition elements. So these example, if you think about hydrogen and beryllium, this group, and like if you see A on the top, these are main groups. B on the top, they are transition metals. Mostly main group elements have similar properties, but when you think about transition metals, they don't have that similar recurrent properties. So that's the mainly about the periodic table. So if you go there, okay, so then let's go to that's a periodic table, and then I want you to show mole and molar mass. This is also another important concept. Mole and molar mass. So what is mole? Mole is a amount. Example, you go to the store and you don't ask 12 eggs, you say dozen of eggs. Dozen is a number for 12. Like that, mole is also an amount, but the difference is bigger amount. If you go and ask mole of eggs, that means you're asking this many eggs. 6.022 into 10 to the power 23 eggs. We call this number Avogadro number. Like you can say, okay, I need 1 mole of pebbles. 1 mole of pebbles contain 6.022 into 10 to the power 23 pebbles. 1 mole of pencils, like that. It's just a number. But how do you relate to chemistry? If you can, before the question, if you can count 1 mole of carbon atoms, that is the, like 1 mole, like say, okay, if you can count 6.022 into 10 to the power 23 carbon atoms, that is 1 mole of carbon. If you can count 6.022 into 10 to the power 23 nitrogen atoms, that's 1 mole of nitrogen. It goes like that. And then if I show you another way of when you count 1 mole of carbon atoms, which is 6.022 into 10 to the power 23, that equals atomic mass, which is 12. So I connected two things. Count Avogadro number of carbon atoms. 1 mole, the mass of it is Avogadro's number. Okay, so let me write it for you again. I hope you can see. Yes, you can see it. You can see it. Okay. So 6.022 into 10 to the power 23 carbon atoms one mole have mass of 12.01 grams. So that is the relationship. Example, okay, before we go to this one, I'm gonna tell you this. I'm telling you 1 mole of carbon, mass of the 1 mole of carbon is 12. What is the mass of 2 moles of carbon? You multiply it by 2, right? Because 1 mole is 12, 2 mole is 24. I can ask question this way. What is the mass of 0.5 mole of carbon atoms? 0.5 means, okay, 1 mole 12, 0.4, 0.5, 0.6. I'm sorry. 1 mole 12, 0.5, half a mole is 6. Okay, now that is the mass. Now I have the mole, I am going to the atoms. 1 mole has Avogadro's number of atoms. 2 mole has Avogadro's number into 2 atoms. Half a mole has Avogadro number divided by 2 number of atoms. So that's how we, okay. Now keeping that in mind, let's go to this question. Calcium is the most abundant metal in human body. A typical human body contains roughly 30 moles of calcium. Okay, now determine the number of calcium atoms in the 30 moles of calcium. So if you know 1 mole has Avogadro's number of atoms, so 30 moles, basically you divide by 30. The number of moles of calcium in a sample, okay. So they ask, okay, you have this many atoms. How many moles? You know you have this many atoms, but you know 1 mole contains Avogadro's number of atoms. You have this many moles. I can ask you question one step further. What is the mass of this mole of calcium atoms? You know mass of 1 mole of calcium atom from the periodic table, okay? 1 mole of calcium atom is 40.078. It's not on my mind, okay? I look at the periodic table. So I take this number, multiply by the mass of calcium. That's how I take it. So that is the mole calculation. Practice these mole calculations. And then, so this is again converting moles to, so if you have the grams, in order to convert grams to moles, basically you divide by molar mass. Example, I'm telling you, okay, you have 24 grams of carbon atoms. So how many moles? So you know 1 mole is 12, 24, 12. In order to get, you get divide 12 by 24. So I hope this video will be helpful for you to understand this chapter. Thank you.